Alright, sixth graders, we're going to jump right into Unit 1 in your math book. This is page 1. Unit 1 is on expressions and equations. And the first thing you're going to do here is you've got this list of skills that you are going to have by the end of this unit. So right now, you're going to read this list, and you're just going to check off anything that you feel like you can already do. So go ahead and pause here until you've read all of those. And actually, while you're doing it, I want you to be thinking of, are there any of these things that you've already used in real life? And are there any of these things that you think you might use at some point in real life? But go ahead and pause now. Alright, did you pause? Did you unpause? Okay. So hopefully by the end of this unit you will be checking off all the boxes in the after column. But if you don't have any boxes checked, well, then that's fine. I mean, we haven't learned it yet, right? Alright, let's prepare for our unit by talking about what we know. Okay, so we've got perimeter, area, and volume. And you should be doing this without me, but just to give you a few hints, just a few. Remember the perimeter, what the measurement is. The measurement of the perimeter is around the outside. Think of it like the fence. So we're going around 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then the area is the inside. So think of that like the lawn. And that is 1, 2, 3, 4, 5 by 1, 2, 3. So how to find the measurement of for the shape shown? You count around the outside. And for this one, you multiply the base times the height. For volume, what the measurement is what's inside. Ooh, what's inside? Let's put, where can I put that for you? Let's see. Let's talk about what it can hold. What it can hold. So that's kind of like if it was full of water, what would the volume be? And how to find the measurement? So you do base times height times depth. You gotta add that third dimension. So base times height, but then also times depth. The formulas. So the formula for perimeter is just side. Is that a formula though? That's not a formula. Let's make an actual formula. Well, for the shape shown, it's just, I mean, they're all the same because it's a square. If it was a rectangle, it'd be a little bit different, but we're just going to do the length of the side times 4. So 4 lengths. If it were a rectangle, you would do 2 lengths plus 2 widths, but it's not a rectangle, it's a square. For the area for the rectangle, you could do length times width. You could do base times height. It means the same thing, but depending on how you learned it before. And then for this one, we would do length times width. Oops, that's a terrible W. Width times depth, or base times height times depth, or base times width times depth, as long as you're doing the 3 different directions. The example units here, that's well, it's 4. We have 4. And then the distance around the outside is 3. If you double check it. 3 and 3 and 3 and 3. Yeah, 3 times 4. And then this one was what? 1, 2, 3, 4, 5 times 3. So this one is 5 times 3. And then this one up here, we got 3 times 2 times 2. Okay, 3 times 2 times 2. So 3 times 2 times 2. 3 times 2 is 6. 6 times 2 is 12. Guess I could put the rest of the answers on. There we go. Situation this measurement could be used for. Well, I'm going to let you come up with that one. Why would you need to know the perimeter of something? Why would you need to know the... I'm going to even put 4. No, wait, there's 3. I want to be sure we're emphasizing the perimeter and area are different, so the outside is all 3s. Okay. Situation the measurement can be used for. Why would you need to know the perimeter of something? Why would you need to know the area of something? Why would you need to know the volume of something? I want you to pause and think of some examples. Ready? Pause. Okay, did you unpause? I hope so. Otherwise I'm going to get lonely over here. So related words, border, length, around, width, and I'm just going to add fence because that's how I always got my 3rd graders to learn it, so I'll use that for you too. Border, length, around, fence. For area, let's do base, height, square, squared, because we use square units. Not square, but squared. You know, like this one is feet. Ooh, is that what they mean by example units? Up here, feet, square feet. Oops, that's not square, that's cube. Square feet and cubed feet. I should have thought of that. There's the example units. These are just the example problems. Squared, width. And for this one, you could use base height, and width, but I also want to emphasize depth. And the units, the cubed feet, so I'll just put cubed. You can kind of put whatever you want. This should all be review. Okay, so once you've got page 2 done, now we're going to actually dive in to the lesson. And in the iReady Math, a lesson is usually a week long. So this isn't today's lesson, this is this week's lesson. It has a different part every day. And the blue pages are pages you do guided with a teacher or an adult or even another student, and the green pages are for you to practice. So here's your little family letter. We're just going to go over it quickly. In earlier grades, you, your student, which is you, learned that a rectangle is a type. Oops, that's a line tool, not my highlighter. I want my highlighter. A rectangle is a type of parallelogram. So just to review, parallelogram and rectangle. Just like a square is a type of rectangle, a rectangle is a type of parallelogram. And a rhombus is a type of parallelogram. Okay, one way to find the area of a rectangle is to multiply the length or base, like I said, they're pretty much interchangeable, and the width or height of the rectangle. To find the area of a parallelogram, you can decompose or break apart. So remember, decompose. Dang it, I did it again. Where's my highlighter? Decompose, which means break apart the parallelogram and compose the parts back into a rectangle. So if you had this parallelogram here and you chopped off this part and stuck it over here, ta-da, it is a rectangle. It's just slanted. And when you slant it, you can put it back together like that. So the base and height of a parallelogram, they're always perpendicular. Perpendicular, remember, means they're like at a 90-degree angle, perpendicular. Forming right angles. The height can be measured inside or outside the parallelogram. So remember, when we're doing the area of a parallelogram, we're not doing a side, we're doing a height. Height is important. It's not side times side, it's base times height. Okay? You'll be learning to solve problems like the one below. What's the area of this parallelogram? Well, it's got the same formula as a rectangle because it is a rectangle, just slanted. You just have to remember we're doing base times height, not side times side. Okay? Using either of these methods, the area is going to be the same. Okay, now this activity is for you to do with your parent or grown-up or brother and sister, as long as they can figure out what you're doing here. So have you noticed you can decompose a parallelogram into smaller shapes? Remember, decompose means break apart. Like, when you throw trash out, it decomposes. A parallelogram allows you to rearrange the pieces into other familiar shapes. Use any combination of the following shapes to draw as many parallelograms as you can. So you're going to take these shapes and draw as many types of parallelograms as you can. Go ahead and pause and spend a few minutes doing that, and then when you are satisfied with your parallelograms, come back and hit play again. Alright, did you draw a bunch of parallelograms? I hope they're beautiful, because we're starting with Lesson 1, Session 1, area of a parallelogram. So, here we go. This is called a try it, so basically you're going to do this part on your own and see if you can figure it out before I teach it to you. So Kenji and Alec are making paper kites for a kite flight. Kenji's kite is a rectangle, so there's Kenji's. And Alec's kite is a parallelogram. So technically they're both parallelograms, right? Because a rectangle is a parallelogram. We just went over that. Each boy draws a model of his kite on grid paper. Does Alec's kite use more paper than Kenji's kite? Which is basically asking, do they have the same area or not? So I want you to try to figure that out in this space down here on your own. And then when you're done, I'm going to show you how I'm going to do it on the next page. But until you've tried it on your own, you're going to hit pause right now. Okay, did you do it? Did you think you figured it out? Let's see if you got the same answer that we're going to get on this next part. Okay, so does Alec's kite use more paper than Kenji's? What did you get? Let's see. Well, I bet a lot of you tried to count the squares, huh? So you probably did this one already. 1, 2, 3, 4, 5. 1, 2, 3, 4. So 5 times 4. That's Kenji's. And that's 20. And whatever, we'll say inches squared. We'll say it's in inches. I don't think they said, did they? And then you probably tried to count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And Alex had 20 inches squared. So they are the same, and if you counted them, that's totally fine. But that's not going to work every time. Okay. And you can put that down here. You counted them. Whatever you did, put that there. Go ahead and pause if you need to. So the words length and width are often used. Length and width are often used to describe the dimensions of a rectangle. When describing the dimensions of a parallelogram, we're going to use base and height, though, because we want to remember that the height is not a side, it's within the parallelogram. So we're going to stick with base and height for now. Any side of the parallelogram can be called a base. So you could flip this, whole thing over, and then it's got a new base. So whatever side you want to use can call the base, as long as you get the height correct. Okay, the base and the height are perpendicular. So notice they form a right angle. That means they're perpendicular. Base and height, perpendicular. For each parallelogram, draw and label a height that corresponds to the side that's labeled the base. Okay, so remember we've got our base marked out here. And remember it has to be perpendicular, so we're just going to go up so that it creates a 90-degree angle. There you go. But now this one's called the base and it's sideways, so we're going to have to keep it perpendicular so that it creates a 90-degree angle. Okay, now the base here is 1, 2, 3, 4, 5 units. And the height is 1, 2, 3, 4 units. On this one, the base is 1, 2, 3, 4 units. And the height is 1, 2, 3, 4, 5 units. Ta-da! Okay, now reflect. In problem 2a, would the length of the height change if you measured from a random point on the same base? Let's think about that. Well, it depends on what you got to make sure you get the same height, right? So the height, if I did the height out here, as long as I remember to stop where the top is, that'd be the same, right? Let's see out here. Yeah, same thing out here. As long as you go from the bottom to the top, it's all the same. Just be sure you don't go in here and go, oh, I'm stuck, I'm stopped. No, you gotta go all the way to the top. So, would it change the height? No. And everyone's favorite part, the explain. The explaining, don't forget to explain. You can't just put no. Would the length of the height change? So no, you just always have to go from the bottom to the top. Or cover the distance from the bottom to the top. Ooh, I like that. You just always have to cover the distance from the bottom to the top. Or from one parallel side to that, that's even better. Because look, on this one, it's not bottom to the top, it's side to side. It's just the parallel lines. From one, I'm going to mess you up now because I'm going to change this distance between the parallel sides. So, to review, these are the parallel sides, so you have to cover the distance between them. These are parallel sides, so you have to cover the distance between them. Okay, you guys gotta remember what parallel means, and you're good to go on that one. Alright, so that's the whole thing for lesson 1, session 1. Now these green pages, remember, are for you to do and show your grown-up. So you've got page 7 and page 8. And then we're going to start lesson 1, session 2 tomorrow. So these 2 green pages, you need to finish them on your own or with a grown-up, show your grown-up, and take a picture and upload them to Canvas for me. If you need any help with anything, you know how to email me, text me, or message me on Canvas. All of those messages I will receive. So good luck.